Today we're going to review ECE Theory by the Galactican Group ECE Technologies Limited. It is a unification of gravity and electromagnetism using Einstein-Curtin-Evans theory of cosmology. He says, fundamentally, magnetic levitation technology involves manipulation of space-time curvature. And he goes on to say it's been used with monorails, and we have this technology today. And given the equivalence of electromagnetism and gravitation, so he's assuming this based on the ECE theory of cosmology. He says that that the electromagnetic field is from the torsion of space-time. And gravity, Einstein's gravity, neglects torsion. This could be true. It could be right. I don't know. But the fact that it's still electromagnetism doesn't change anything. So he also talks about here that this is provide a further illustrate the utility and potential of the geodesic fall process. The potential of the geodesic fall propulsion system technology is enormous. Well, yeah, if we had that, we'd have warp drive. Besides the obvious spacecraft applications, such a propulsion system technology could be applied to planetary vehicles and the automotive industry. This technology might alleviate several concerns such as emissions. It's hype, all right? This is just hype. When he gets down past the table of contents and everything, we get into a little more meat of the problem. And he goes on to define that from the principles of ECE theory, c, the speed of light at any given point in spacetime, is shown to depend on the curvature of spacetime at that point. To be more specific, the coordinate speed of light is a variable in general relativity and is dependent on the curvature of space-time, which affects your rulers and clocks at those coordinates. So he's not wrong in saying that. So we can move on from that. He says that ECE theory also shows that coupling between the background potential of spacetime can be established by appropriate electrical or mechanical devices. This coupling manifests as amplification of the potential in volts of such devices as said devices resonate with the background potential energy of spacetime. It kind of makes sense, but not really. In general, to counter the gravitational field of spacetime, at a given point in spacetime, the potential energy of spacetime, which is voltage, must be increased. Here he's talking about voltage like it's a absolute parameter, whereas in electromagnetism, voltage is a relative measurement. It's the difference in potential between two points with different charge densities or different surface charges. And he's talking about it like it's an absolute value. Like the background of space is referenced to something, but he never says what. The background potential energy of spacetime. Conventionally, gravitational potential energy is related to the gravitational force. The gravitational potential energy, he defines as K, of an object is mgh, which is essentially saying if I lift my calculator up off the table, I now have this much potential energy, where this is the mass, g is the gravitation of the Earth, 9.8 meters per second squared, and my height is about half a meter. It's not anything new. He's just talking about gravitational potential energy. He says that from ECE theory, considering that gravitation and electromagnetism are both expressions of space-time curvature. Again, he's pulling this out of thin air, I guess, but I mean, it's not conclusive in any way that that's true. Where gravitation is the curvature of space-time and electromagnetism is the torsion twisting of space-time. K is defined as phi. So he's defining this potential energy of space-time as mass times g times h. So just Newton's potential energy. K equals phi can be viewed as related to space-time curvature. Thus, the gravitational potential energy at any point in space-time can be regarded as the potential energy experienced by an object at that point. The curvature, in other words, the gravitational field of space-time at any point determines the geodesic path and velocity an object at that point would experience. So if curvature was induced at a point in space-time, an object at that point could fall along the resulting geodesic at a velocity dependent on the degree of said induced curvature. This induced geodesic fall vector would be different from the natural geodesic fall vector. In the Earth realm, raising the altitude of an object opposes gravity, increases, in other words, it increases space-time curvature and increases the object's potential energy. Therefore, by increasing phi, anti-gravity effects can be induced. It seems to me that he's confusing electromagnetism and gravity, and taking electromagnetism and calling it gravity. That's what I see. Because he hasn't mentioned any kind of coupling yet or anything. So here he goes. The ECE theory shows that coupling between the background potential energy of space-time, which he calls volts again, can be established with appropriate electrical or mechanical devices. This coupling can cause a significant increase in phi in the neighborhood of such a device. Thus, gravitation is encountered in that device neighborhood. The field equations for ECE theory are used below to show analytically how this coupling works. I'll get there in a minute, but I want to show some inconsistencies here. Here, he calls phi the scalar potential of space-time. He said it's volts, and then he defines it as mgh, which is energy. Volts is energy per charge. So phi is not volt. Phi here is energy, not volts. But if we go a little further, you're going to see that phi is volts, not energy. So there's a confusion there. Spin connection resonance. This is supposedly the key coupling, spin connection resonance, SCR. ECE theory shows that properly designed electrical or mechanical devices can resonate with phi. The ECE field equations can be used to define an engineering framework for the design and implementation of devices suitable for coupling with the background potential energy phi of spacetime. In other words, achieving SCR. So here he goes from the general resonance equation, a differential equation for a generalized item Q of x, Qi of x, one of I elements, where f of x is the driving function. We have this. Now I just want to point out that this is pretty much almost exactly the same as the Abraham-Lorentz equation, where zeta 1 is the damping factor, which is, if you're familiar with my work, that's what I attribute gravity to, is radiative damping. But I also have the Abraham-Lorentz equation, and this is not much different. He's got a different term here, but it's just a multiple of the element itself. So he says, from ECE Theory field equations, where bold-face denotes a vector quantity, del is the gradient vector, and the following relations are used. Now, see below, I mean down here. I'll get to that in a minute. He says E, which is undefined. He doesn't say what it is, but we'll assume it's the electric field, is minus dA dt minus the gradient of phi minus omega 0 A plus phi omega. And B, being the magnetic field, magnetic flux density, I should say, is the curl of A minus omega cross A, where A he calls the vector potential of spacetime. But it's, in everyone else's book, it's the magnetic vector potential, and it has units of volt-seconds per meter, or Webers per meter. Phi is the scalar potential of spacetime, but for it to be E, the electric field, it has units of volts, not energy. So he's changing his specs for phi. Omega naught is the spin connections, is the scalar spin connection, which has units of radians per second, and omega is a vector spin connection that has the unusual units of radians per meter in order for these equations to be dimensionally consistent and make any sense. So he also says, considering the electrical case, we let A equal 0, which just gives you the Coulomb law, plus this extra term here. So he replaces E with these two terms, and he gets this. Dimensional analysis checks out as long as you use these units. Everything checks out. And the ECE Coulomb law thus gives the expression del squared phi minus omega dot, the gradient of phi, minus omega dot, del dot omega, or the divergence of the omega vector times phi, are equal to the charge density over E naught. This resonance equation for phi, the scalar potential, excuse me. This is a resonance equation for phi, the scalar potential. The resonant frequency is the divergence of the omega vector. But that's not frequency. Frequency has units of hertz, or radians per second. And here he's using the divergence of a vector that has units of radians per meter, which means this has units of curvature, 1 over meter squared, not frequency. So I don't know why he calls it a frequency. You don't usually get a frequency from a divergence equation either. So it doesn't make a lot of sense. He says the divergence of the spin connection, which is what it is, this term spin connection resonance is used. If phi is the space-time scalar potential, then at spin connection resonance, phi should be maximized. Is there any reason for that? He doesn't give one. The effect is to induce space-time curvature in the maximized potential field phi. The degree of induced curvature and the resulting geodesic path are determined by the driving function, which this is just the scalar charge density divided by E naught, which is essentially volts per square meter. The induced curvature and resulting geodesic path would be different from the natural curvature and geodesic path. Thus, natural gravity is opposed fundamentally by increasing the space-time gravitational potential energy, phi. The anti-gravity effects are generated. No. He's talking about an electric field, not a gravitational field. And he's talking about a divergence being spin connection or frequency of rotation or something, but there's nothing here saying, other than he calls it that, that makes it that. So there's some background assumptions being made. And normally we think of in general relativity that a particle in free fall is following a geodesic. A particle that gets pushed off of free fall by an electromagnetic field is no longer on a geodesic. It's non-metricity, as my friend David likes to call it. So it's not a geodesic fall if it's being propelled by the electric field. Work is being done. When you have geodesic motion, there's no work being done. But here, obviously, if you have an electric field causing a path to change of a particle, work is being done. So that's not geodesic motion. Okay, he mentions, these are my notes, he mentions the electric case and Coulomb's law, so it implies that E is the electric field and B is the magnetic field and A is the magnetic vector potential. But he doesn't call it that. He calls it the vector potential of spacetime, the same as with phi. It is implied to be the Coulomb potential, but he calls it a scalar potential of spacetime. He is renaming known quantities, and that's always a bad sign. Also, the resonant frequency is not a frequency in time, it has units of curvature. How do we make sense of this? I don't know, I'm struggling. So the driving function principles for spin connection resonance capable devices and systems. Given that the resonant frequency is the divergence of omega, and omega is a rotation vector of the magnetic field, which usually has units of radians per second, not radians per meter, is reasonable to consider devices based on rotating magnetic fields. A rotating magnetic field or two counter-rotating magnetic fields can be used to achieve resonance. Spin connection resonance in this case, phi is amplified in the neighborhood of the rotating magnetic fields. And then he jumps to a conclusion and says gravitation is countered and electric energy is available. That's a long shot, and it's not even true. So when you spin magnets, you have rotating magnets, you create a homopolar motor that has a voltage difference between the center and the outside, where the velocity is faster and the acceleration is faster. So it's a relative voltage from the middle to the outside. It's not relative to the earth or gravity or anything else. So it's not countering gravity, it's just generating a voltage, which if I connected a wire and a resistor or a load between the center and the outer spinning edge of the magnet, I would see a voltage and it would generate some power based on how much power I'm putting in to cause this flywheel magnet to spin. So he jumps to this conclusion with no anything to back it up. Specifics for the driving function. Well, before he had the driving function was just Coulomb's the Coulomb constant, or the Coulomb charge. So here he redefines it. The objective of the cross-field device is to couple with the torsion of spacetime to achieve spin connection resonance and maximize phi. By definition, so here he's defining, omega I is the rotation vector of the ith magnetic source. Bi of r is the field of the ith magnetic source, and ui of t is the magnetic moment of the ith magnetic source. From the engineering perspective, 18, the use of two counter-rotating magnetic sources suggests a flexible, effective spin connection resonance device technology. This is because a simple, straightforward magnetic torque-based driving function can be defined. We can use the driving function. F drive is magnetic moment 1 times magnetic field 1 plus magnetic moment 2 times magnetic field 2. Okay, so this is a magnetic field equation for magnetic potential energy, not force. This is magnetic potential energy. It's nothing new. We've known about it for decades. The magnetic moments add, if you have all the magnets on a disk like Alexei's Graviflyer and they're all pointing the same direction, then the magnetic moment of the rotating disk, the magnetic moment of the stationary disk is the sum of all the magnetic moments on the disk. When you rotate it, the magnetic moment doesn't really change much, if at all. So he's saying that phi is maximized in the region between the counter-rotating magnetic sources, countering gravitational effects in that region. This is not true. If you have two counter-rotating homopolar motors with the magnets and magnetic moments facing in the same direction, what you'll get is one where the voltage difference from the center to the edge is positive, and the other one where the voltage difference from the center to the edge is negative. So yes, between the outer edge that's positive and the outer edge that's negative, you're maximizing the voltage. So he's understanding that part of it. But it has nothing to do with gravity. It's just a homopolar motor made of magnets. There's no coupling to the Earth or the gravitational field, and the Earth is not a reference that it's opposing. So the rest of this is just getting into hype, and his proposed circuits, which are, really just a resonant circuit, doesn't really say anything about gravity. Now, if you come down here, he's talking about magnetic levitation, and I did a presentation on this last year about magnetic levitation. And you need a magnetic field to start with, and then another magnet or two that are spinning to oppose it. And yeah, it's called the levitron. That's the generic name. And this is the way the spin axis precesses to keep it afloat above a base magnet component. It precesses. And Falcon Space and I have been working on understanding electron parametric resonance and nuclear magnetic resonance, in which electrons or protons or nuclei do the same thing. Protons in water will do this if resonated with the right frequency above a magnet. In an NMR machine, that's exactly what they do, and then they look for the decay time of these events to image inside the body. So, the levitron device dynamics. Defining phi top, which is, he marks over here as the potential energy of the spinning top, as the scalar potential energy of the top. Again, he's calling phi potential energy, but it has units of volts in the math. It is shown from 11 that equilibrium is achieved if the gradient in phi top is equal to 0. If the second derivative of phi top with respect to z is greater than 0. And then he says if those conditions are true, vertical stability is achieved. And here's his equations for horizontal stability. Now, out of the blue, he pulls out these equations that are Einstein-like in form. And these are probably coming from the ECE Theory paper, but there's nothing here that is involved. He's just saying that there is an equivalence between this and this electromagnetic equation, which has nothing to do with gravity. But this is the same exact equation that I put in my presentation that I came up with for anti-gravity with magnetic moments. However, the problem is the Earth's magnetic field B is orders of magnitude too small. It's only at best like around 45 microtesla. And I've given some thought and chatted with ChatGPT 4 about how we could generate a large-scale magnetic field above the Earth that we could use. And it's impractical and expensive to be able to do that even over a limited area. So it's not a useful thing in that sense because it has to be enclosed. But I mean, what he's saying here is the gradient in this potential energy, and then he calls it phi, where he's calling phi a potential, but this is not a potential anymore. This is a force. The gradient of mu dot b is a force, not a potential. He calls phi the driving function, and this phi is the scalar potential. So it doesn't make a lot of sense, and he's equating gravity as electromagnetism, or he's saying that electromagnetism is gravity because of this ECE theory. But as I pointed out, electromagnetism is not geodesic motion. So, in conclusion, this theory is based on this ECE theory where electromagnetism is the torsion of space-time, which he's reading into it stuff that isn't there. And he's not really understanding gravity at all. He's barely understanding consistent electromagnetism. So here you've got your levitron top between two or between one or the other magnetic base. And yeah, it'll work either way. You can make it levitate above a magnet or you can make it levitate below a magnet. But it doesn't levitate without the magnet. And the Earth is not a strong enough magnet to make it work. So this is his bubble area he defines. And again, it's between two magnets and has nothing to do with gravity other than it has enough magnetic force to counter gravity because of the magnets above it or below it. Anyway, I hope that made some sense to you, and don't buy into this or don't put too much faith in it because it's really not what he thinks it is. I don't think there's any kind of fraud going on here, but I do think that he is misunderstanding the theory and what it really means. Again, if you wanted to levitate something, let's say using this equation, and you didn't want to have a magnet underneath you, then this is electromagnetic levitation requires exhausting enough electromagnetic field in terms of photons to generate enough thrust to cause that lift. And in doing so, photons move at the speed of light, and that is 1 over c is your power to thrust ratio. So, I mean, 1 over c is going to give you 300 megawatts per Newton, or 3 gigawatts per kilogram is what you need to lift something and levitate it using electromagnetism. And there's no way around that unless you put a magnet underneath it, which then gives you the energy that you need. But on the surface of the Earth, relative to the magnetic field of the Earth, there's orders of magnitude of energy and exhaust to create a force to counter gravity. And he's just not understanding that. This only works because he's got a magnet below it or above it. It's not going to cause anti-gravity in the way that we want. I hope everyone understood. If you have any questions, you know where to find me. Take care. Bye.